Good day, everyone. Welcome to my first lecture on online transaction processing. Okay, so the short name for online transaction processing is OLTP. I am Professor Rage Udakiran from the University of ISO. The outline of my presentation is as follows. First, we will talk about what is a mini world. Then we look at what is OLTP. Okay, how do we build OLTP systems using entity relationship model, relational schema, and SQL. So this will be the topics that we will be discussing in this presentation. The first one is mini world. Okay, when we use the word mini world in the field of databases, we mean it here means mini world represents a specific application that you want to observe or study. Okay, so imagine that a world is a collection of applications, okay, like sensor network, e-commerce stores, agriculture, and so on. So we have many applications in the real world, and when we say a mini world, we are talking about a only one application in that world. Okay, so here is one example. Okay, so in Japan, okay, most of the people are aged. Okay, so aging population Japan has. So these people have one major health problem, and that health problem is they have cardiorespiratory problem, which is mainly due to the air pollution. So this is our imaginary application. Okay. So when people are suffering with air pollution, what government of Japan has did is it has set up a sensor network throughout the Japan to collect the pollution levels at different time intervals of a day. Okay, so you can see here the red dots that you see are the representations of the sensor stations that are located throughout the Japan. Okay, so each sensor at every hour they record various pollution, various pollutants, for example PM 2.5, SO2, and so on. Okay, so you can see that at 00 hours sensor 1 has recorded 23 units of PM 2.5, 0.6 units of SO2, and so on. Okay, so this network is generating this data. Okay, now assume we have a ecologist and he wants to store this data and process it. Okay, so this is the task. So people in Japan are suffering with bad air pollution. So to tackle this pollution problem, a sensor network has been developed. Okay, and this sensor network, okay, is collecting the pollution levels at hourly intervals every day. Now what we want to do is we want to store this data and process this data effectively. How do we do that? To okay, we use online transaction processing systems to do it. Okay, so when we talk about online transaction processing, we should know what are they. Okay, so basically when we talk about online transaction processing system, it is nothing but a data processing system used for gathering the data, processing the data, and updating the data. Okay, so if you take air pollution data, okay, shown in the example, OLTP system is used to store the air pollution data generated by various sensors. Okay, then we can process the data. So whatever data we need, we can take it. Unnecessary data also we can delete it, and then we can update the data. For example, any sensor value is incorrect and the value has been changed, we can update that data. Okay, so these three operations called GPU, okay, gathering the data, processing the data, and updating the data. So these are done using OLTP systems. Okay, so now the key question is, okay, I have data and there is a software called online transaction processing or a database management system. Now the key question is, how do I build OLTP systems? Okay, to build a OLTP system, we should understand three important topics. Okay, these three important topics are step by step. Okay, so the first one is we should learn ER schema. Okay, so entity relationship schema we have to learn. Next, we have to learn relational schema. Okay, and then we have to look at learn SQL. So these are the three steps in which we have to learn and develop OLTP systems. Okay, so now let us look at the entity relationship model. Okay, this is the abstraction level. So when we say about entity relationship model, people generally call it as ER model. Okay, so the beauty of ER models is that it represents a mini world as entities and their relations. Very, very simple. Okay, and please remember, entity relationship model or ER model is a abstract data model. Okay, because it abstracts the data in the form of entities and relations. Okay, a key advantage is real world is very easy to describe using ER model. So let us see how we can build ER model, okay, for our application, that is air pollution data application. Okay, first, rule number one. So there are three rules. First one is we have to identify entities, and those entities have to be represented as boxes. Okay, so if we understand or if we see the data set, okay, we can see that in our air pollution data we have two entities. The first one is the sensor entity, the second one is the observations entity. So we have two entities. Next, once we identify entities, we have to identify the attributes of these entities. Okay, so sensor has name, its unique ID, address, and location. So these are the four attributes for a sensor. Similarly, observations, when we talk about the entity observations, it has three attributes. One is ID, pollutant, so name of the pollutant, and its value. So what was the value observed by this pollutant? So we have two entities and attributes. Okay, now the third step is attributes that are unique to a entity, okay, have to be underlined. For example, small id is uniquely identifies each sensor, right? This is the sensor id, so we put underline for id. Similarly, we put observation id is underscore because it represents the unique key. Okay, so every value of this attribute is unique in the data. Once we establish the entities, what we do is we establish relations. Okay, so when we talk about relations, the relations are expressed with a diamond symbol. Okay, so sensor takes observations, and when does the observations are taken? At a particular date. So this will tell us the entire system, how the elements within the system are related to one another. Okay, this is of the abstraction level because there is no data involved in it yet. The beauty of its of ER model is its simplicity. Okay, you can see it's everything is so simple and easy to understand. So I have given the ER model at a very high level. Okay, ER model has different topics. Okay, to master. So I have given some symbols. Please go through them by yourself in the later time. I am skipping discussion about these entity expressions and relationship expressions due to the interest of time. Now we look at relational schema. Okay, relational schema is at the logic level. So generally when we talk about relational schema or relational model, it follows first order predicate logic. That is, data exists in the form of tuples grouped into relations. Okay, now a database organized in terms of relational model. Okay, if you are storing the data in a relational model, we call it a relational database. Okay, as I told you, relational model is a logical model because it follows logic. So if you see the relation model, it looks like a table. Okay, so it has a table name or a relation name. So we use the symbol R to represent the table name. Each table has attributes or columns. Okay, these columns are generally unordered. So this is one key advantage. And then the entire table is called relation. Okay, each tuple, okay, each row is called tuple, and the rows from second to last are called body. Okay, it is the table. Table has a table name or the relation name. Table has attributes, unordered attributes. Okay, the first row of a table is called heading. The remaining rows are called body. Body of a table. Okay, so here is the thing. So we have the ER schema. When we convert the ER schema, okay, into relational model, we get as follows. Okay, we say sensor ID. So the entity is sensor. So the entity became the table name sensor. The attributes, okay, became the column names. The attributes of the entity became the column names. Similarly, observations became the table name. The attributes of observations became the columns. Observe that the unique keys of these entities are underscored. Okay, so the underscore still exists to represent that they are unique and they are the keys. And then most important, when we are creating a relation table, okay, when we are creating a table for a relation like text, then we bring in the keys followed by its attributes. For example, text is establishing relationship between sensor and observations. So we say take table contains ID of sensors, ID of observations, and the date. So this information is stored by the table. So very simple to create. So in the real world, first what we do is we observe the real world and we create this ER schema. Once we have the ER schema, we create its respective relational model as tables. Once we create the tables or once we create the relational model, we have to now create those relational model into the database, okay, into the physical level. So we create those database or tables at the physical level using SQL. SQL stands for structured query language. Okay, so to understand SQL, we should look at the basic operations on the disk. When we look at the basic operations on the disk, okay, we generally see that uh, disk has three basic operations. One is read a file, write a file, and update a file. Among these three operations, okay, reading a file is a read operation, while write and update, okay, so these two will form a write operation. So basically we say that, okay, the basic disk operations are read and write. So in the same, so based on these two operations, we will have the SQL queries. Okay. So in the SQL, when we want to store the data using SQL, we have to understand the architecture. Okay. So this is the architecture of the database management system. Okay. So users or programs will access the database programs, and then they will be using queries to connect and access the data. Okay, so the data is stored in two formats. Okay, one is the metadata. So metadata is more like heading of a table. Okay, I'm giving you in the abstract sense. Okay, but do not take it literally, so easy for understanding. Next is we will be storing the data. So we have metadata and data. When I say data, data is nothing but a observable fact that can be recorded. Okay, for example, Mr. Smith is 50 years old person, a male, and he lives in America. So that is the data. Okay, when I say metadata, then we look at the header information. So we have name, age, sex, country. So these four attributes form the metadata. Okay, from in the metadata we will also define its type. So we say name is a string, age is a real number, sex is a string, country is a string, and we can also incorporate constraints. For example, age can't be more than 120 years. Okay, so this way we can enforce the constraints. So let us look at this example. So I am giving you a table. Okay, now in this table you have to find what is a metadata and what is the data. Okay, I have give you 30 seconds time to think and come up with the answer. Okay, I hope you have come up to the conclusion which is metadata and which is data. But anyway, the answer is the first column. Okay, the header of this table is called metadata. The body of this table is called data. Okay, now visualization. So if we execute any query, okay, please remember, over the data will be the metadata. When the user executes the query first comes and checks the metadata. Okay, whether it is a insert query, update query, or read or slash select query, every query will first access the metadata. Okay, if the query is correct, then it will be working on the data, and then we will get the output. If the query is incorrect, we get the error. Okay, so this is the thing. Now we look at SQL for metadata and SQL for data. Okay, two different sections. So when we talk about SQL for metadata, okay, there are only three commands to handle metadata. They are create, alter and drop. Okay, so these are the basic operations. So when we talk about metadata, we say create table, table name, alter table, table name, and we can say add a column or delete a column. Next we can say drop a table. So these are the basic SQL queries for handling metadata. Okay, so how do we frame the sentence? For example, I have to create a table. The structure is very simple. Create, I have given here create table, table name. In the braces, you give the name of an attribute. Okay, for example, SID. SID is a integer type and it is a primary key. So this is the constraint. So this way we specify. Then again we come back, we can say name, varchar, not null, height, weight, height float, address is a varchar. So this way we try to create a table. Similarly, if we want to alter a table, we say alter table, table name, add column. So in this case I say add table students, add column, the name of the column is country, which is a varchar. Okay. Similarly, if I want to delete a column, you say alter table students, delete column, the name of the column we have to mention. Okay. If you want to drop a table, you simply say drop table, table name, and the entire table will be deleted. Okay. Now we have SQL for data. So for metadata is only the creation, alter and deleting the data. But uh, for SQL for data we have four. One is select, insert, update and delete. Okay. So these are the four pillars of the basic operations. Insert, that is used for inserting the data. Update is used for updating the values in the data. Delete is used to delete tuples or rows within a table. And select is used to select any row or rows that are needed for the user. The basic syntax for insert is insert into table name, columns, values and value name. So this is the traditional syntax to insert data into the database. Okay. Similarly, if you want to update any value in a table, the command is update table name, set column, okay, equal to particular value, column 2 equivalent to particular value. So we set the values and we mention the condition. Please note that mentioning the condition is of utmost important. Okay, because if we don't use where condition, the changes you are specifying in the update will be reflected in the entire table. Okay, so here is one example. Okay, I have a students info table. Okay, here if you see Takahashi, the okay row with SID 3 Takahashi has empty gender information, has no gender information. So I want to put is I want to say Takahashi is a male. So then what I do is update students info, that is the table name, set gender equivalent to male. So I am saying gender is male and username is Takahashi. So once I specify it, then the third row, the containing the user Takahashi will have male as the gender. Okay. Next one. delete statement. So delete statement, as its name implies, it is used to delete the records in a table. Okay. Then next one is the select command. Select command is used to select the data from the database. Okay. So you have data here. If you execute the select query on the data, the result of that select query is called result set. Okay. So the syntax is select columns from the table name where group by. So we can use this select query, okay, to select the necessary data. Okay, so this is the same thing. So here is the example. Assume I have a student's info with the following table, with the following user information. Now assume there is one user who wants the names of students and their gender. Okay, from this table we need to find out student names and gender. So the SQL query we write is very simple. We say select name comma gender. Please don't use and we don't need. Okay, so select name gender from students info. Okay, this will help you to get the data containing only the columns name and gender. Similarly, if anyone wants name and address, you simply say select name address from students info. This will output the required information from the users. Okay. Group by is a very important command. It is used, okay, to group the rows based on the values of a column. Okay, we use group by to count, find the maximum value, minimum value, sum, average, and so on. Group by is one of the bread and butter command for the analytical purpose, for the analytical people. Okay, so assume I have this data. Okay, student details are there. Now I want to find the average height of the students based on their gender. Okay, so if the student is female, what is their average height? Similarly, what is the average height of female students? So to do this, what we do, we say is select. Okay, answer is in the side note, but anyway the SQL query is select average height. Okay, select average height from table name, that is student underscore info. Okay, select height, select gender. Okay, average height, okay, from student table group by gender. If we give this query, then we get the necessary date. Okay, to practice more, please refer to the following websites, especially www3schools.com. Go to this web URL, learn various SQL commands and practice them. Thank you very much for listening. Okay, now I will end the talk.